Hi all, I am here with my new video on chapter The Phases of Matter. Let's start. In this video, we will learn about ideal gas behavior and gas laws. In appropriate conditions, many samples of gases show ideal behavior. We assume ideal behavior of gases because all the laws which governs gas behaviors apply only when gas behaves ideally. There are four characteristics of a gas we need to describe its ideal behavior. They are as following. First of them is pressure, it exerts. Second is volume. Third, its temperature. Fourth, number of particles or number of moles. On these slides, there is short description of the gas laws. Most of real gases behave ideally at low pressure and high temperature. Conversely, at high pressure and low temperature, real gases fail to exhibit ideal behavior because either the particles attract each other significantly or the volume of particles is no longer negligible in relation to the volume of the container. Boyle's law states that an increase in pressure is accompanied by a decrease in volume at constant temperature and number of particles. Pressure multiplied by volume is equal to constant. Graph rectangular parabola. When we draw a graph P against V, for solving mathematical problems, this equation is used in the following form. P1 V1 is equal to P2 V2. Charles' law. According to this law, the volume of ideal gas is directly proportional to the Kelvin temperature. Volume divided by temperature is equal to constant at constant pressure and number of particles. Graph straight line which drops to zero volume at minus 273.15 degrees Celsius or 0 K. For solving mathematical problems, this equation is used in the following form. V1 by T1 is equal to V2 by T2. Gay-Lussac's law. According to this law, at constant volume and number of particles, increase in pressure is proportional to increase in temperature. P divided by T is equal to constant at constant volume and number of particles. Graph straight line. For solving mathematical problems, this equation is used in the following form. P1 by T1 is equal to P2 by T2. When we combine Boyle's law, Charles' law and Gay-Lussac's law for ideally behaving gases, it can be written as following. Pressure multiplied by volume divided by temperature is equal to constant at constant number of particles. For solving mathematical problems, this equation is used in the following form. P1 V1 divided by T1 is equal to P2 V2 divided by T2. Avogadro's law. According to this law, at the same temperature and pressure, equal volumes of any ideally behaving gas contain equal number of particles. It can be written as following. Volume divided by number of particles is equal to constant at constant temperature and pressure. In equivalent form, V1 divided by N1 is equal to V2 divided by N2. The ideal universal gas law. According to the ideal gas law, P multiplied by V divided by N multiplied by T is equal to R, or we can write in this form P multiplied by V is equal to N multiplied by R multiplied by T, where R is a molar gas constant that depends on unit of volume and pressure, where P is equal to pressure in atm, V is equal to volume in liter, T is equal to temperature in Kelvin, and N is equal to number of molecules. Then value of R is equal to 0.821 liter multiplied by atm divided by mole multiplied by Kelvin. When we use SI system, pressure in pascals and volume in meter cube, then value of R is equal to 8.31 joule per mole multiplied by Kelvin. In our next video, we will learn about the kinetic molecular theory of gas behavior. So please like and subscribe to watch new videos.